All right, it's Mr. Conyers again. Thank you for joining me. We're going to go ahead and go over case, what is it? Case 8, challenge 2. Let's go ahead and jump into the Geniverse. So we're picking up where we left off here. You should have completed challenge 1 of case 8 by matching the remaining 2 drakes. So we are ready for challenge 2. Hightailed it. Looks like we must determine the genotype of each mother drake and then submit our answer to the journal. So this is another one where we'll need to use this icon up here to submit in writing our thoughts to the journal. Now remember, as I presented in the last video, I am able to look at these journal responses, so I'm excited to see what you write. Now, the key to solving this problem will be identifying what the possible genotypes of the fathers and mothers are based on their offspring. I'm going to help you do one similar to the last challenge, and then you're going to figure out the other 2 and submit your claim. I'm also going to help you format that claim a little bit. So let's go ahead and take a look at our parents here. Now we are focused on the tails, so we noticed that the mother has a long tail, the father has a short tail. So I'm going to take a little picture of these and bring them into our workspace over here so that we can start talking about their possible genotypes. So here's our father. And then I want to get an image of these mothers too. Okay. So one thing that would be important to notice is that the father has a short tail, and the mother, actually all of the mothers, have long tails. So in the last video, we talked about the order of dominance, long being most dominant, kinked being intermediate, and short being the most recessive. So that actually gives us a big clue here as to what the father's genotype has to be. And I say has to be because there's only one possible genotype for dad. We would describe his alleles as being short. Now, mom, we said, has all long tail phenotypes. So that means that all of those drakes have at least one allele for long tail. Now I'm writing this in 3 different places because, as you might have inferred, there are 3 different genotypes that are possible for a long-tailed drake. They could be purebred for the long-tail trait, and their genotype could be long. They could be hybrid, one of 2 variety of hybrid. They could have a kinked tail, or they could have a short tail. Now let's think about what this would mean for their phenotypic and genotypic ratios if these drakes were bred together. So I'm going to open up a new page here. We're going to take all of our possible combinations and copy them over here so that we remember. And then I'm going to create 3 Punnett squares to represent our 3 possible outcomes. So bear with me for a second here. Oh, you know what? I'm going about this all the wrong way. Why wouldn't I just do that? Okay, so let's go ahead and add the parents to each of these Punnett squares. So for the father, we'll just put his alleles across the top. Those are boring, right? He's homozygous recessive, so short, 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 all across the top. Moms, we have identified could be one of three different varieties: long, long, long kinked, long short. So go ahead and fill in the insides of these squares now. Okay, and then let's do the phenotypic ratios. Remember, we could also do the genotypic ratios for these as well, but we don't particularly care about the genotypic ratios in this particular problem. We're much more focused on the phenotypes because that's what's presented to us in the Geniverse. So, if the mother drake had this genotype long, long, then we would expect the offspring of this cross to be 100% long-tailed. And that's because they all have at least one dominant allele for the long trait. So that's masking all of the alleles they have for the short trait. If we look at this cross, we would see 50% would be long. But then we have this other 50% that have one kinked and one short. Well, based on what we learned from the first, we know that the kinked is dominant to the short. So that other 50% would be kinked. Then looking at the third one here, we see from the top row that we have another group of 50% long. And then we also, where'd that one go? Did I just not fill that out? We also have 50% with two recessive alleles. So that means that in this cross, 50% would have a short tail. So let's go back to the Geniverse. We'll do our first cross. So remember that the stats button is really useful in identifying what the ratio is. It looks like we have a 60-40 split here between long tail and short tail. Let's go ahead and breed them again, because 60-40, we didn't get that ratio for any, but remember, as we continue to breed them, over time their stats will become closer to what the ratio we expect is. Okay, so after this many generations, the ratio is 51% long tail, 48% short tail. If we go back to our ratios here, that means that in this case, the mother is long short. That's her genotype. Long short, because their offspring were 50% long tail, 50% short tail. So what I need you to do is switch out the other mothers, figure out what their ratios are. But I can go ahead and write my claim here. The first mother is long short. So when bred with short father, the offspring were 50% short, 50% long. My reasoning is that based on the results of a Punnett square, this is what we would predict. So you go ahead and do the other two. Make sure that all three mothers make it into your claim. Then go ahead and hit save and post and come back for the next video. As always, thanks for watching.